All right. Welcome everybody to today's Getting Started with Kubernetes and Rancher 2.0. We have people joining the line as we speak. Just if you're tuning in, we are just getting started now. I'm just going to wait a few moments for more to join, and then we'll get going here. All right, I think that's good. So let's get started. Welcome everybody to today's Getting Started with Kubernetes and Rancher 2.0 training. Really excited to have you all. We have about an hour and a half together to really get you, a solid technical introduction to Kubernetes and Kubernetes concepts. How you can work with Rancher to, you know, deploy Kubernetes clusters, provision clusters, and manage workloads on those clusters. We're going to keep the slides to a minimum. We definitely do have slides, and I believe my colleague Jason has got some new and improved ones for you as well. But this will mainly be demo, demo, demo. We'll get hands-on really quickly, and on that note, we really welcome questions. So if you have them already, please start putting them in the question feed, and we will answer to the best of our ability. As we go through, we'll pause periodically to answer questions that you have. This is an intro training, so if something isn't in the in the scope of the training, we might defer to our other resources like our forum and Slack, but I'll get to that in a minute. For now, just to introduce myself, my name is Matthew Shear, community advocate with Rancher, and my colleague who will be doing most of the technical part of this demo is Jason. Jason, thanks for being on the line, bringing us your knowledge and wisdom.
Thanks for
Really
having
good
me.
to have you. Yeah, absolutely. And so everyone, so Jason and I are super available, after and before these trainings. Our contact info is here on the slide. And so as well, these slides and this recording and the questions as well will be posted to our website after this training, and everyone will get an email with the link so you can see the recording, the slides, and the questions. Just a little bit of context to set kind of the ground rules. We hope that you come in to this training with some basic Docker understanding. You kind of understand, how containers work on a fundamental level and a basic level. And if you don't, I think you'll still get a lot from this training. So don't worry. This is still probably beneficial for you. And if if you've never used any containerized applications or infrastructure, there's a lot of great resources online on the Docker site and on our blog and in our docs as well. So you won't be left out to drift. If you want to follow along with your own Rancher instance, as Jason is going through the demo and provisioning Kubernetes clusters, go to our quick start guide. You'll be able to get up and running with an instance of Rancher, in just a few minutes. Again, the way to get to this link, if you're on our website, is just to click that deploy button in the top right corner, and you'll be brought to the quick start guide. One last thing, the resources outside of this training are extensive. We have a huge community. Everything Rancher does is open source, and Kubernetes is open source as well. So there's a ton of people working on this stuff. Check out our forums, forums.rancher.com, as well as our Slack channel. We have a few different Slack channels for Rancher users and Kubernetes channel. I believe it's rancher.slack.io or maybe slack.rancher.io. It's on the last slide. We'll have the actual URL, and you can get more information and help there. So on that note, I'm going to turn it over to Jason to start getting into the meat of the content here. Are you ready to be the presenter, Jason?
I'm good to go.
All right, let's switch this over.
Okay.
Cool, I can see your
So,
screen.
all right. So as Matthew said, my name is Jason Dan Brackel. I'm a senior solutions architect at Rancher. I am also the organizer of Kubernetes Philly. So Kubernetes is near and dear to my heart. And since joining Rancher, I've really been loving what it uh, brings to the Kubernetes community. But let's talk a little bit about why Kubernetes. For those who have been following Rancher for a while, we switched over um, support for multiple container orchestrations to just Kubernetes. We moved from the 1.6 platform to the 2.0 platform. And the reason behind this has to do a lot with with Kubernetes momentum. The interest in Kubernetes has grown sustainably. It is a immensely scalable and robust platform that is releasing often. Large software companies like GitHub, like a lot of our clients, have publicized their use of Kubernetes, and major IT vendors have recently added to their offerings as general available Kubernetes as a service. For example, Azure AKS, Google GKE, and of course Amazon EKS. And you can see this isn't just a Google project. This spans well above and beyond just what Google started a little over 4 years ago. There are many, not just independent developers, but other large companies like Red Hat, like IBM, and like Microsoft that are heavily involved in contributions to the Kubernetes code base, to plugins to Kubernetes, and to servicing up Kubernetes as a service like the aforementioned projects. But even if you have Kubernetes and it's a great platform, you have other operational challenges, like the questions we see here. There's significant complexity around multi-tenancy, partitioning clusters for efficient resource use, centralized monitoring and authentication, and this is kind of where Rancher comes in. I would describe it this way: Kubernetes is a really, really high-performance engine. And Rancher is coming at this as, we love this engine, but we want to build a really nice car around it and make it easier to use on a day-to-day basis. Kubernetes development is also moving very rapidly. There are tens of thousands of commits over the last year. That's accelerating. The top 5 GitHub projects are all Kubernetes-based projects, and lots of pull requests and GitHub contributions. There is no LTS version of Kubernetes, like in Ubuntu, for example. There's a quote-unquote minor release every 3 months, and these releases really aren't minor. They could have brand new objects, breaking changes from alpha to beta, and there's all kinds of things that change from version to version. And unlike the days of where you're on one version of Windows forever, and there are even organizations that are still using Windows 7, for example, it's actually more beneficial to be on the most up-to-date release to make sure that you can support, actually it's now 1.11 that came out just last week, that you can support 1.11, but you can still have a migration path from, as far back as 1.6 or 1.7 all the way to 1.11, depending on your need. But that creates significant operational challenges for IT infrastructure teams. So having some help along the way is a really good thing. And then usability. Kubernetes abstractions are really, really powerful, but there are a lot of them. They're fine-grained and they're complex. There's a steep learning curve. And the knowledge that you may have had coming from containers in Docker or from no containers at all in tiered development really do not translate well over to Kubernetes. And so a lot of the times, even reading the documentation may not be completely clear, and you end up like this gentleman here with his head stuck in the washing machine. But if it's Kubernetes, the washing machine probably still runs just fine. It's just a little painful to use. So Rancher Kubernetes makes it better together. We have a very easy-to-use interface for Kubernetes configuration and deployment. We can manage multiple infrastructures in our multiple clusters across multiple infrastructures, both in the cloud and behind your data center. And we also provide workload, RBAC, policy, and project management for your Kubernetes-based applications. And the enterprise, the open source version of our software is the same as those with 24/7 enterprise grade support. We don't hide things from open source customers. The open source product is the same as the enterprise product. We just sell support to keep the lights on. So Rancher 2.0 is a complete container management platform. We're taking the best of breed IaaS, or maybe your data center, and we are supporting all the various different flavors of Kubernetes providers, whether it's a Kubernetes as a service like an AKS, or our own Rancher RKE, or just an IaaS provider like EC2 or Microsoft Azure. And then we're building on top of that, on top of cloud native and Kubernetes, vanilla Kubernetes recipes, and then serving up easy to use unified Kubernetes management, things like RBAC and policy security, and then adding some of our own things on the top layer for application management, for easy application monitoring and logging, as well as our own app catalog and simplified user interface. But all the things that we built are vanilla Kubernetes. We actually utilize a Kubernetes object called a custom resource and a custom resource definition. So all the Rancher bits are native Kubernetes. They don't get in the way of Kubernetes. We're there just to enhance your Kubernetes experience. Rancher 2.0 looks a little bit like this, and on the bottom layer you have your Kubernetes running, and the various pieces that are going to be the Kubernetes, and then Rancher server, which is just tying into the various tying in and living on the Kubernetes clusters, phoning home back to the Rancher server to make sure the Rancher server understands what the current state of the world is, and the state of all your Kubernetes universes. So we're going to start with a little bit of Kubernetes 101. Now, this is just enough to get you started. I did an informal count this morning of the 111 API objects. There are about 50 different API objects in Kubernetes today as of 111. A few less than 110, a few less than 19, 118, etc. We're going to walk through 5 of them. But these 5 are enough to get you up and running, probably to solve that 60 to 80% of use cases for working with Kubernetes. Let's start with pods. Pods are the smallest unit that can be deployed in Kubernetes. They consist of 1 or more containers that are always scheduled together, and each pod has a unique IP address. Containers within a pod can speak to each other via localhost. So they're in the same network namespace, they share file system access, they're essentially under the same PID. This way they are as if they are on a single machine, and pods will never be scheduled across machines. So pods can be a little confusing. And don't worry too much about that. Sometimes pods only contain a single container, and thinking of pods as containers is a good starting point. But an example might be here. This is a multi-container pod. So on the left, if you don't recognize the icon, it's Nginx. That's a web server. On the right is Redis, which is a key value store. From the perspective of Nginx within this pod, it can speak over localhost to 6379, which is the default Redis port, as if they were on the same machine. And to each of these individual applications, they think they're on their own clean machine in a freshly booted copy of the operating system with a fresh memory state right from the start. What I would recommend, if you're not familiar with distributed systems, a pod is one of the distributed system design patterns, much like the Gang of 4 object-oriented programming design patterns. This book is the start of that conversation around design patterns. I highly recommend that you would read this to help you start to form that shared vocabulary between people designing distributed systems. I brought that up because I occasionally will use the term sidecar in the previous slide. I don't want to assume you know what that is, but this book is definitely worth your time as you're exploring Kubernetes. Next object is replication control, or replica set. The replica set is actually the next generation version of replica controller, and these define the desired state of a group of pods, and they drive from current state to desired state in the controller manager. So a replica set might look like this, where I've defined in my replica set that my pod out there from my first example, that I want 12 of these running within my cluster. And let's say I'm a klutz. I've got my cup of coffee in the data center, and I inadvertently take out one of the nodes. or could just be a power shock, bolt of lightning, random solar energy from the sun. But for some reason your node goes down. The replica set's job is to make sure that the desired number of pods get scheduled throughout your cluster. Now, this does require that the amount of resources required to run those extra workloads is available. And there's all kinds of, it's one of the power of Kubernetes is to be able to prioritize and schedule workloads as needed. That's the job of the replica set. Generally, you won't be creating a replica set by itself. There's another object we'll talk about shortly that actually creates the replica sets. So in this case, we have the pod, and replica sets are in charge of the number of pods that we want running within our cluster. Next step is deployment, and this is a level of abstraction above the replica set. The deployment's job is to create and update replica sets. It allows you to easily scale and perform rolling updates. And it might look a little bit like this. So here we have our V1 replica set. This is just a subset of the image I showed you earlier. We have 4 of these running right now. And let's say V2 comes along. Deployments allow us to define how that upgrade happens. In this case, this rolling upgrade says, hey, let's bring up the new version now, and then roll back the old version. So two of our V2 of this specific application is now deployed to the cluster, and then the V1 versions start going away. Eventually, you get to a state where everything is V2. If there's a problem, deployments can also roll back, and you end up with the V1 copies as well. So the deployment's job is to define how upgrades should happen, whether it's a rolling upgrade, whether everything shuts down at once and everything else comes up, and the various batch sizes that you have for that. That's the deployment's job. So the deployment does that through updating the replica sets we mentioned earlier, which in charge is making sure the right number of pods are running within your cluster. So we now have a deployment with a replica set of running pods, but they're not exposed to the outside world. Right now, they're just running in the cluster. Nothing has access to anything outside of the pod. So now we define a service, and that service defines an internal DNS entry that can be used to refer to a group of pods. So I'm going to make that really clear. That's internal DNS to the cluster, not necessarily external DNS. And then the different types of services will depend on whether or not that application exposes the outside world. But it provides a consistent endpoint for the group of pods regardless of type. So different types include node port, cluster IP, load balancer, host port, and external service. And there's even a headless service. But they each have different functions. Cluster IP just opens up your application to other applications within the cluster. So this is east-west traffic within the cluster and not to the outside world. Unless serviced by an ingress, which we'll talk about later. A node port exposes your application via an IP address and port combination for every node it's on. And then a load balancer, in this case, is a layer 4 load balancer, so IP-based load balancer that works in tandem with a cloud provider to create public IP addresses for your application. I'll show off an example of this shortly. I was spinning up a cluster for a demo, and I can actually show off what that would look like in the real world. But services basically work this way. A client has the ability to say, public IP address, add a specific port that goes into a service IP, and then inside of Kubernetes, there's a process called kubeproxy, and kubeproxy's job is to route traffic to an instance of your pod running somewhere within your cluster. So really, I have 3 arrows here for simplicity, 1 for each host, but really there should be 4 arrows per host there. That would just look really, really messy. But the idea is service is handling the routing from the outside world via layer 4 through the service into an individual pod. So next are config maps. So we have an instance of an application running a service. But what if I want that application to have different configurations for different types of environments? So a use case for this might be a dev QA prod scenario. So this allows us to store any arbitration configuration value and files. Because it actually could be mounted as a volume within the pod, but it can be exposed, either as local storage, volume mount, or as environment variables, and it just decouples the storage configuration from the pod spec itself. So it may look like this: same pod spec, different configuration based on the configuration map. Actually, I made a mistake here. My name should be dev config, QA config, prod config, but I think you get the idea. The idea that you can have the same key value pairs for a single type of pod for different environments. So they could even run within the same namespace, within different namespaces. One thing to keep in note. Config map, secrets, and I forget the third one. All are essentially stored as secrets within the cluster, so they all have to have, it's one name per namespace. So two objects cannot have the same name within a namespace. So just keep that in mind as you're working with things like config maps and services, for example. And then ingress. So whereas before we were talking about, for example, load balance service or host and node port that are all dealing with layer 4 and IPs, ingresses deal with layer 7. They define how traffic outside the cluster can route inside the cluster. So this is one way where you could actually route to a cluster IP from the outside world. And that's used to expose Kubernetes services and route traffic between client to internal services based on factors like host and path. These ingresses are implemented by an ingress controller, which is just another load balancer. The default in the feed tends to be the Nginx ingress controller, but there's also ones by HA Proxy, AWS ELB. You could even go as far as, there's a project out there called External DNS. It's a Kubernetes external DNS subproject, and that will actually monitor your ingresses and change your cloud provider's DNS rules. If you're like on AWS with Route 53 or Azure with an Azure DLS, it will actually create DNS entries for ingresses and services as you create them. Really cool project. But it looks a little bit like this. You remember earlier we were dealing with our services, dealing with an IP. In this case, your application name dot whatever. When the ingress controller sees that, in this case, the ingress controller icon in this example might be a whole set of ingress controllers that's load balanced. So you'd have a front-end load balance, client would hit the front-end load balancer, front-end load balancer would hit one of the ingress controllers, and then based on either URL, something in the URL name will route that to a specific set of pods. In this case, our Nginx Redis example from earlier. But this is at unlike services, which are layer 4, this is ingresses at layer 7. So before we start with Rancher 2.0 101, let me pause and see if there are any questions.
Let's see. So far, no. Jason, people are just attentive and following along. So if anybody does have questions, please post it. Otherwise, keep going.
All right. So now we're going to start with Rancher 2.0 101, and we're going to walk through setting up Rancher, setting up a cluster, authentication and security options, and then we'll walk through storage, projects, namespaces, catalogs, and the CLI. So we'll walk a little bit. We'll get as far as we can with the time we have. We'll take a few questions and pause as we go. But by all means, ask questions as we go. If you have anything about Kubernetes specific to these topics, or about Rancher 2.0 itself, or how we're working with things, by all means, ask. So it's now demo time. Oh, and again, I just wanted to mention this before I jumped into my demo. You can join other Rancher users in Slack at slack.rancher.io. Look for the hashtag Kubernetes channel. I'm out there. I'm at JVB, and there are a number of other Rancher employees who hang out there from time to time. I'm there almost all the time because, like other field engineers, I tend to work from home a lot. So I just make myself available because I love this stuff, and we have a great community. If somebody from Rancher isn't available, some of the community will probably come along and help you. And look for the little blue cow icon. The users little blue cow icons are letting you know, hey, they're Rancher employees, and they're here to help. So let's get started. So I always bring this up because, by all means, check out my GitHub. Most of the things that I write for potential client proof of concepts that we're working on, or things internally that we're messing around with, I post publicly on my GitHub. So feel free to follow me on GitHub. A couple of the blog posts that I've written recently that have been published by Rancher, the code is right here on my GitHub, like the symmetric server on Rancher 202. Or as the aforementioned Kubernetes external DNS project. I wrote a post on that, and the code, the walkthrough for that is here as well. But by all means, follow me here. Follow me on Twitter. I'm either JVB out there or I'm Jason Van Brackel. I'm sorry, I have a hard to spell name. But let's jump in. So I'm going to go to docs.rancher.com, which will redirect me to the /docs. I'm going to go to 2.0. And we're going to go to installation and single node installation. Now you'll notice there are lots and lots of different ways to install Rancher. This is by far the easiest way to do it. So we're going to walk through this. Feel free to follow along. I may go a little bit faster because I pre-baked my demo, but I'll talk through each of these steps a little bit. Any gotchas that I've run into as I've done this over and over again that I've seen working in this system. So first, provisional Linux host. Those three operating systems, Ubuntu 16, Red Hat 7.5, or Rancher OS 1.3.0, there is a number. Those are supported operating systems. You can use other operating systems. We can't guarantee they work. Like I've had questions about will it work on Arch Linux? Yeah, probably. Will it work on Gentoo? Yeah, probably. I'm a big Slackware fan. I go back a ways, and my first Linux distro was Slackware 2 off of a CD from a computer show. So if it can support Docker, Rancher will likely run on it. If it won't support Docker, then you may have an issue. For a list of our supported operating systems and Docker runtimes, check out the Rancher Terms of Service. And this is for those who wish to have a support maintenance contract, but also all of our testing goes against the versions that are in this compatibility matrix. So Ubuntu 16.04, RHEL on CentOS 7.5, Rancher OS 1.3, those specific versions of Kubernetes. What a lot of it isn't there yet because it's really fresh and new, and it'll come it'll come as soon as we run it through our testing to make sure it's actually compatible with all of our stuff, and then specific versions of Docker. And you might ask yourself, hey, why isn't 17.06 in here, or why isn't 18 in here? And that really goes back to the Kubernetes community. The Kubernetes documentation states the supported versions of Docker for Kubernetes, and we're just kind of mirroring what they say. So, your mileage may vary with 18 or 17.06. I've used 17.06 without problem, but that's only to say that the Kubernetes community hasn't gone about running it through its paces to say, hey, this is the supported version. Kubernetes is built by a set of special interest groups, and these special interest groups have specific special interests. Like there is a SIG node that is involved in how Kubernetes works along with nodes. There's SIG Windows for how Kubernetes works along with Windows Server containers. I'm a part of that group. SIG Docs is dealing with the Kubernetes documentation. So all of these different groups are in charge of different parts of the Kubernetes system. So different parts may move at different speeds depending on community involvement from various corporations, and leadership. So we give you some basic hardware requirements based on the number of nodes you're going to have with CPU and RAM. You can see this is commodity hardware, really small. If you want extra large systems, give us a holler. Go ahead, go at this point, install one of our supported Docker versions. You'll need that on your nodes as well. Everything's out on Docker Hub. If for some reason you're behind a firewall and you can't get to Docker Hub, you'll have to use an air gap. Or in some corporations, you can get to the outside world, but proxy is a problem. You have to set some no proxying variables. I believe we've had some articles on that fairly recently, or at least some code on it that's gone back and forth. General communication traffic through Rancher for not just say single node install, but various other types of installs. Every type of install needs 443 from the Kubernetes cluster back to Rancher management plane. This is so that our custom resources within Kubernetes can open up a WebSocket to the Rancher management plane for the purpose of sharing information. And we keep alive that WebSocket throughout the life of Rancher management plane so that we can communicate in a consistent manner with each of these different types of clusters. The only exceptions to that 443 rule is in cloud-hosted Kubernetes, so AKS, GKE, EKS. We also require that 6443 inbound be open so we can talk directly to the Kubernetes API, just because the nature of cloud-hosted Kubernetes is different than custom host or RKE or even IS provision. And then an IS provisioned, like an EC2 or an Azure, DigitalOcean, VMware, you also want port 22 inbound open so that we can SSH in and actually install Docker on your behalf. So next, choose an SSL option and go ahead and install Rancher. In this case, Rancher is just, you're going to just be grabbing Rancher right from Docker Hub. You have a couple options for certificates. I'm not going to run through all of that for let's encrypt or bring your own certificate. Those are pretty complicated scenarios just because certificates are fun. And by fun, I mean not fun. But let's go. We'll walk through the self-signed certificate. And it's really simple. It's just a Docker command, Docker run, put a restart in there so that it will restart unless it's actually explicitly stopped. And you'll want to share out 443 and 80 and grab the latest version of Rancher. So in my example is slightly different. I'll actually open up a terminal for my Linux machine where all of this is running. You can see here, this is a single node Docker. I just have my Rancher running. It's been up now for 2 days. It's up most of the time. I think I restarted a couple of days ago. And I'm just redirecting 443 and 80, only because my internal setup's a little bit different. And if you just want something repeatable over and over again, I actually keep in my field engineering utilities, I keep just a start Rancher container. If I cat this, you'll see it's really just a Docker run command. I'm mounting a volume so that I can get at the etcd files in case I want to move them somewhere. And then I'm just grabbing. I'm grabbing explicitly 204. Our example says latest. That is 204 right now. And then from there, you now have Docker server up and running. Now, this isn't a production ready scenario. This is just for local machine only. It's really good for development environments. I would not recommend this for production environments, but it's enough to get you up and running. We have install scenarios for highly available, for external load balancer, for air gap, and also check out the backup and rollbacks because everything in Rancher server, unlike Rancher 1X, which is backed by MySQL, everything in 2.0 is backed by etcd, which is the same backing store that is used for Kubernetes. We do that just for consistency's sake. So if you are maintaining a highly available and backupable and restorable etcd cluster, you're backing up Rancher. But from there, once you've run the Docker command, whether it's a Let's Encrypt certificate or not, you now have Rancher server up and running, ready to start spinning up Kubernetes clusters. So I'm actually going to log into mine now. I'm using a self-signed cert. You'll probably see something similar. So I'm just going to add a security exception from my box. And the login screen will come up. Now out of the box, when you first bring yours up, it'll ask you for a URL. What's really important is that URL is routable and addressable by the Kubernetes clusters you'll be spinning up. So if you do a HTTP localhost or a HTTP 127.0.0.1, you're going to have pain because the Kubernetes clusters will not be able to route back to your Rancher server. In this case, I'm using a system called NoIP that's actually gives me a public address for my laptop, so that so that I can route from my Kubernetes clusters out on Azure, out on DigitalOcean, back to my laptop so this all works properly. Now, I'm going to log in using GitHub. It'll ask you for a admin password, admin username when you start up. I've already have a cluster up and running here, but let me start with authentication. So we're at the global level. We're going to float down through 3 levels today. One is global, the next is cluster, and then is project. But let's start with authentication. Out of the box, as of Rancher 204, we support 3 types of authentication: Microsoft Active Directory through Exchange. So you would create a service account to your Active Directory that has the ability to see your users and groups. And then you could use those users and groups to control RBAC across all of your Kubernetes clusters. This is a killer feature of Rancher, coming from being a guy who did not use Rancher before I started working with Kubernetes and managing multiple clusters. The idea of the ability to do integrated authentication simply out of the box is just absolutely awesome. We also support Azure AD, which is Azure Active Directory in the cloud, not to be confused with Exchange. It doesn't deal in directory trees like Exchange. It's very, very different, and they overload that name, which is why I bring it up, because I got really confused by that about 3-4 years ago when I started looking at Azure AD when it was in preview. And then what I'm using today, I'm using GitHub authentication. I use it because I'm on GitHub all the time. It's nice to be able to demo that, and all of my organizations that I'm part of. Within Rancher, I have access to and can actually give Rancher groups access to parts of my cluster. Also, because I don't have a running Exchange server sitting here on my laptop, and it just makes it easy to show this off. So let me stop for a second. Any questions before we move on to the next part of the demo as far as storage goes?
Yes. There's a few. I'm glad you paused.
Okay.
So let's see. Amelia, I'm probably going to butcher your name. Amelia asks, is it possible to set up Rancher just like a bare metal setup if you don't want to use Docker?
So Rancher requires 2 things. It requires an operating system like an Ubuntu or Rancher OS, and it does require the Docker engine. So one of the other ways of doing Kubernetes is you use open containers or some other container runtime besides Docker. For some of the functionality that we have, we do require Docker engine to be available specifically for the Rancher bits. Now, that's not to say you couldn't run multiple container runtimes. For example, I was able to take Kelsey Hightower's Kubernetes the hard way. For those of you who are learning Kubernetes, check this out. And Kubernetes the hard way is Kelsey Hightower's step-by-step bootstrap Kubernetes by hand, and it's a learning tool. His versions for Google Cloud. There's versions for AWS and for Azure. But this spins up a pure open source version of Kubernetes using just basic run C and gvisor as a secured runtime container engine, but no Docker. So earlier versions of this actually use Docker. The later versions have taken Docker engine out of it. But for the purposes of using Rancher needs Docker engine to do its job. That's not to say you couldn't have Docker engine and Open Container Runtime and Kata containers and gvisor runtime that could all be controlled via different annotations. That's well beyond the scope of this, but it is possible. It would just be a matter of changing the container deconfiguration to support all those via config and via annotation. Another question?
Yeah, there's a couple more, and then I think you should go on. The next one, Powell asks, is it possible to use Ubuntu 18.04 as a Rancher host?
So this demo that is running a single node Rancher is running on 18.04. We won't support 18.04 in Kubernetes, and it's not part of our green path. But it probably will work. I've not done a full-blown 18.04 cluster yet. And 18.04 is significantly different than the 17 and 16. They made some major changes in Ubuntu between 16 and 18. So your mileage may vary. It will likely work. I just can't state because I haven't done it myself.
Yeah, cool. Okay, last one, and this is from a call, and it goes back to the Kubernetes concepts slides.
Okay.
He asks, are ingresses running on all the nodes in a replica set in some kind of coordination? In other words, all the nodes in a cluster.
So I'll go back to the ingress slide really quick. So the ingress controllers are configurable to how you run them. Rancher by default, we install the Nginx ingress controller as what's called a daemon set. Daemon set means one instance of the pod running per worker node or per schedulable node, essentially. But that could be instead of using a daemon set, you could set it up as a deployment where it's one per number of workers that you have, or any other way that you want it. The important thing is that you're routing it properly from your front-end load balancer to wherever and however it's running. But yeah, Rancher out of the box, when we actually install an ingress controller on your behalf just to make it a little bit easier so you don't have to go through that. We're doing it as a daemon set. One thing of note that actually doesn't work if you want to use the Kubernetes external DNS subproject, which I explained in the blog post on that about a week or two ago.
Cool. All right, sir. Yeah, go for it.
All right. So I'm going to talk about cluster creation. I already have one up here. I'm actually going to import another one because I think it should be done by now. We'll see. But I'll go to add cluster and talk about different options for adding clusters to your system. So one way of doing that is using a hosted Kubernetes provider, Google GKE, Amazon EKS, or Azure Kubernetes service, or you can import an existing cluster. And you could actually create a cluster on one of these hosted providers and then import it later. That's one of the examples I'm going to show. The next way to do it is via an infrastructure provider. It's on EC2, Azure, DigitalOcean, vSphere, and under the covers, we're using Docker Machine. So if the driver is supported by Docker Machine, it might work, but these are the 7 ways in which that we support doing this, and they're all Docker Machine drivers. So we're actually using this in the Kubernetes provider world. We're calling out to the APIs on our backend to these various providers, saying, "Hey, spin us up a cluster with these attributes." And then once it's up and running, we just hook it into Rancher. In the infrastructure provider world, we're actually calling out to these infrastructure providers. They're spinning up infrastructure. Once the infrastructure is done spinning up and we can SSH in, we'll SSH in. We'll install Docker. And then once Docker is up and running and we can see that, we'll go and install Kubernetes. There are many, many ways to install Kubernetes. We're using the Hypercube container. So the Hypercube container image contains all the different binaries required to run Kubernetes, and you execute them with various command line arguments to determine which one you're going to use inside the container. So Hypercube is a well-known way of doing that. We're automating the deployment of Kubernetes via Hypercube. And then if you have something where you're spinning up Kubernetes some other way that you're spinning up your IaaS and your Docker engine some other way, like let's say you're using Terraform along with Ansible to set up your IaaS and your Docker engine, and that already works. You want to change that. You go in here into custom, and I'll walk through custom a little bit because this actually lets me share some of the options. So regardless of which one of these you choose, you have member roles, which is basically saying, hey, I want to give these users access to this cluster. And this could be either an individual user or a group within your organization. So if you're using Active Directory, it could be a group within Exchange. If you're in Azure AD, a group within there, or GitHub, a group here. Coming in a soon-to-be released version of Rancher will also include LDAP, and then a later release after that will have SAML as well. And then from there, we have different cluster options. The Kubernetes versions always look for the Rancher 2 dash something. The Rancher 2 versions are the ones that are meant for Rancher 2.0. The Rancher 1 version are meant for Rancher 1. That's all to say. These aren't changed in any way. These are vanilla Kubernetes. We just maintain our own sets of the supported versions that we use. starting from 110 and going all the way back to 1.8. Anything earlier than 1.8, you're on your own. You can import it in. It may or may not work. Network providers. We will also install and set up a software-defined networking infrastructure for you. Our default is Canal. There's also Flannel and Calico. Canal is kind of a best of both worlds, where it's Flannel for your software-defined network overlay, and Calico for your network policy. Describe the differences between all the advantages is well beyond the scope of this, but Flannel is basically virtual networking. Calico is micro firewalls, would be the best way to describe it. Canal is kind of the best of both worlds. If you use Canal as your default, we'll actually set up network policies that will prevent things from speaking across projects. And then you can require a supported Docker version, in which case if you try to use an unsupported Docker version, it'll actually yell at you. Or you can allow unsupported Docker versions. I'll talk about pod security policy. We have time. It's a little beyond the scope of today's talk. And then cloud provider. Cloud provider works with the Kubernetes Cloud Control Manager, Cloud Controller Manager to negotiate the conversation between Kubernetes and the cloud provider. They're all configured a little bit differently. In Amazon, you're setting up with your client key and your secret key. In Azure, you're setting up a full-blown service principal. And then we also support custom cloud providers that go outside of our out-of-the-box versions. And this is beyond the scope of today, but if you want layer 4 load balancers, you need a cloud provider set up so that Kubernetes can talk to your cloud provider to create public IP-backed load balancers. In a custom scenario, once you have all that set up, we'll just tell you to run a Docker command on each of your nodes, and then it will, once etcd and your control plane are up, you'll see it here. In an import scenario, I'll run through right now, or actually in a IaaS scenario, like I said, where we set up everything for you, and then we can also have an import scenario where we import a custom cluster. So I'm just going to import a cluster right now. You can see the member roles. To say that's really all I have is member roles. I'm going to create, and then that's going to have me run a specific kubectl command against my cluster. So I'm going to walk out to my. Just got two things. I don't think I have to do. I think the cluster admin role is. I can't remember if it's in 110 or not. We might have some issues there because I know AKS has some idiosyncrasies to it that I don't remember off the top of my head. And let's see if my Kubernetes service is up and running. This is actually one of the slower ways of getting Kubernetes up and running, because actually what it does under the covers actually creates piece by piece your Kubernetes cluster. So it is up and running. We're going to get kubectl working against it just so that we can add it to our platform. So I already have the CLI. I do get credential. All right, so I now have a kubeconfig working. And then let me just make sure it's been running, because I can actually do a browse. Oh, that won't work here because I can curl it. I should now have that up and running. And indeed I do. I'm using outdated browser. Yes, I am using outdated browser. Curl is an outdated browser from your perspective. But the Kubernetes dashboard is up and running and working, so we know that my kubectl is now working, and my kubeconfig is set up for AKS demo. And I can do a me make this so it's easier on your eyes. There we go. So good, I have 3 nodes ready. And I'm going to actually run that command now from Rancher so I can import this into my cluster. And since I'm running with self-signed certificates, I need to use this bottom one. And what is happening here is I downloaded YAML from my cluster and piped that into kubectl and hit apply. So we created the cattle system namespace. We created a service account called cattle, a cluster role binding, a secret for the credentials to talk to the server, RBAC rules, and then a deployment and a daemon set. So if I do a kubectl and get all the namespaces, you can see it created the cattle system namespace. And if I kubectl get all, we now have a cluster agent running, as well as node agents, and then a number of deployments and replica sets. Not sure why that node agent spun down, but we'll just let that do its thing. And now I have my AKS platform ready to be managed, just as if I had created through the ag cluster, import it into Rancher. So now that we've actually created a cluster, let me pause here. Any questions?
Yeah, there are a few. This one from Amelia might be moot at this point, because he asked it before you started importing this cluster. But he asked, how do you import a Kubernetes self-managed cluster running on AWS to Rancher?
So yeah, it'd be very similar. It would be a matter of setting up kubectl to that AWS cluster, and then just running that same command in the context of that AWS cluster.
Right. Okay, cool. Couple more. Patrick asks, is LDAP, specifically Open LDAP, supported for authentication backends?
That will actually be in the next release. That will be as soon as it's done. Open LDAP is the primary feature that's targeted for the next release. Any day now. It's one of those things where I'm watching the engineering channel to see when that's going to be released, because we have POCs we're working with where they're chomping at the bit for LDAP. So very, very soon.
Awesome. Okay. On that note, actually, releases. Rajan asks, can we expect a Terraform provider for Rancher 2.0, and are you planning integration with Jenkins X anytime soon?
So Jenkins will work alongside with Rancher via our APIs. So you can create your own Jenkins plugins for that, or you can just talk straight through Kubernetes through existing Kubernetes plugins. Those paths will work with Jenkins, since Jenkins is so malleable and flexible. Everything within Rancher has an API object, where it's basically an HTTP-based API, just like Rancher 1.0, where everything that is doable in the UI is doable from the REST API. And we have those vertical ellipses throughout the system to show you how to go about, for example, creating a cluster via something like a Jenkins. If you wanted to, you would fill out the various pieces here, hit show request, and the curl, here'd be an example curl command for doing just that. So even if there wasn't a supported plugin for Rancher 2.0 specifically, all of these things are doable via HTTP REST APIs. As far as a Terraform provider, there actually is an existing Terraform provider out there targeting Rancher 2.0. We didn't create it. We've done a little bit of testing with it, but the Terraform does not deal well with nested data, and that's how they chose to go about doing their RKE work with Terraform. And it's a little bit kludgy. Usually when I'm using Terraform to spin up nodes, I'm doing there's actually I think I have a Terraform modules out in my GitHub. I'm doing the Terraform apply, then taking the output and then building an RKE config from that into an RKE up. And then that's building out my Kubernetes cluster, and then I'm actually installing Rancher via Helm chart. One of our other developers, Jason Greathouse, has actually gone through and created a Helm chart specifically for installing Rancher and for installing. There's also a Rancher HA one he's working on. Those are not officially supported workflows yet. But it's something that we're working on is for field engineering. But our HA install process is probably your best. But you could Terraform your infrastructure, take the output, build an RKE config, run RKE up, and then install Rancher, that way via our HA instructions.
Awesome.
Any other questions?
That's it for now.
Okay. So I'll go down now at the cluster level because we have 2 clusters we can work with. I'll walk through cluster features. So every cluster, we give you the ability to see what's going on in your cluster. We're monitoring the health of various components like etcd, the controller manager, the scheduler, and various nodes. You can run kubectl right from within the browser if you see fit. You don't go through the hassle of getting kubectl set up on your local machine. And it pipes right through to the browser. You can see I have a bunch of things running here because I use this demo environment pretty frequently. Or if you'd like to actually use the authentication from Rancher on your own command line, you can just download the kube config here, put it in your kube config for your application, and then be up and running. You see which, for example, right now, if I do my CLI, I have a lot of different tools. So, like kubeps1, which it tells you, am I not logged in? Maybe not. Huh. I don't have kube1 script from my SSH. So let me just tmux in real quick because I know I have that plugin running. You see down here in my, let me shrink the window so it's visible on the screen right now. I'm using a tool called, this is not being helpful, 1 second. Windows is helping me by resizing my window to larger than I want it. Thank you, Windows. It's just not going to behave. So I have various tools like in here, like kubeNS and kubectx that will allow me to change what cluster I'm talking to on the fly. And the one I have also for tmux, I like the terminal multiplier. Down here in my lower corner, you can see I'm currently attached to AKS demo and default, but I can change my context on the fly via kubectx. That should have code complete. It doesn't have code complete right now, so it's probably some SSH'd in. But I could kubectx into any other cluster that I want, or change namespace to the cluster. That all has set up for my CLI. And these are tools that are not Rancher tools, but they make my life easier because I deal with so many clusters on a given basis. But that way, I'm actually using my authentication through the system. I can do a kubectl get all and see my Kubernetes service running. But all I have to say, you have multiple ways of doing authentication, based on how you want to talk to your cluster. So we're using vanilla Kubernetes authentication constructs to build this out, but it's running through our authentication system so that your integration between Active Directory or LDAP in your system all still work, but in a native Kubernetes sort of way. But one thing of note, if you're running Rancher, you're running multiple clusters, make sure you have a local user, so not just authenticating through your LDAP provider, AD provider, but also a local Rancher user, like the admin user, so that if for some reason your end user store goes down, you can still get into Rancher server. And likewise, every cluster you create, you want to have a native cluster there as well, just in case something comes up, so that if for some reason Rancher goes down, you can authenticate into your Kubernetes cluster some other way. for every cluster, we can see a list of nodes. Now, in our Azure example, I don't have the ability to scale nodes because if it was an imported cluster and Azure is in charge of my cluster. But in this case, because I'm using an IaaS provider, which is DigitalOcean, I actually can scale my worker nodes as I see fit. And what will happen is they'll create those nodes in that cloud provider's way. Once they come up, it'll SSH in and install Docker. And once Docker is up, it will install the Kubernetes worker bits into the system so that these are now usable by Kubernetes. And once they're up and running, they'll be completely usable. It takes just a couple minutes. You see it's now waiting for SSH. Once SSH is available, it will install the Kubernetes bits. In a case like a managed Kubernetes, like the one here in Azure, I'm going to actually go in and scale that one as well. And then because our custom resources are constantly monitoring the state of the Kubernetes cluster, when the new nodes come up, they'll just be immediately available. So I go ahead and scale this to say 5, and then once those 2 nodes come up, and it'll have the scaling operation isn't instant, but as soon as those nodes are up and calling home, we'll see them in Rancher running. So if I were to go out to that cluster now, so one thing of note, there is an upstream bug in Kubernetes that causes this problem specifically in Azure. These things are running just fine; they are healthy. It's just an issue that we have to live with until the upstream Kubernetes stuff catches up. But right now, we only see 3 agents. Eventually, once those 2 spin up and are calling home, they'll pop up here as well, because we're constantly monitoring the state of the Kubernetes cluster. So let's talk storage for a second, because storage is a complicated thing in Kubernetes. There are a number of ways to do storage. I can run a full day class on storage pretty easily. But we make storage in Kubernetes pretty simple. We give you the ability to add a volume within Rancher with various different plugins. So these are all plugins. We didn't write these. They're available by default. We're just packaging them and making them a little bit easier for you. They all have their own various ways of setting them up. Don't try to use an Amazon EBS disk if you're running on a platform that is on Azure. It's just not going to work right, and these require the cloud provider up and running. But right from here, you could create different types of disks. If you had like an NFS server already running, you go in, you type in your path and your server, and then it will just work. You can then define that against a specific storage class. So let me just talk through this a little bit. In Kubernetes, you have the idea of persistent volumes and storage classes. Storage classes are categories you define of different types of storage. So it could be NFS storage, it's really fast. It could be NFS storage, really slow. It could be a good example of this might be the storage class around Amazon EBS, for example. So Amazon EBS disks, you can have SSD disks or HDD disks. That could be fast or slow or in different zones, encrypted or not, and you would just create different storage classes for the different types of disks that you want to make available to your Kubernetes users. So with what they will ask for storage by its class name, and then if there is storage available by that class name, they will receive that storage, and if storage is not available by that class name or some volume that they know about is not available, it will just error on them. I won't go any deeper than that on storage. We just make it a little bit easier to use the pretty UI to do something that is actually a fairly complicated thing. Any questions? Let's stop for a second. Any questions here before I move on?
Let's see if there's. So Vilas asks, does Rancher support AWS IAM role instead of AWS access key and secret keys?
I don't believe so, but I have to check on that. I believe everything right now is through keys. Like I said, ping me on the Slack channel. I can look into that, but I do believe everything is client key and secret key for things like the different node templates and things of that nature.
Awesome. Okay, next question. Yang is asked a question about load balancing. Can Rancher manage load balancers, for example, AWS, ELB, and self-hosted F5?
So Rancher does not do that, but Kubernetes can do that. So you brought up F5. The F5, what's it called? The big. Let me look this up because I just looked at this the other day. F5, what's it called? It's called Big IP. The F5 Big IP platform actually has a Kubernetes connector for it. And the way that works, for Kubernetes. So the F5 Big IP connector actually will monitor your ingress and services, and if it's configured properly, it will go into your F5 and modify the F5 rules to handle your load balancing into your cluster. For things like Route 53, for example, I would leverage external DNS. There is a sub-project. They used to be called incubators. They're not called sub-projects. The incubator program has been deprecated. But the external DNS sub-project will actually modify things like Azure DNS, things like Route 53, and some of your other various DNS services to change those on the fly as needed. So as you're creating your ingress rules and as you're creating your services, it will create those, it'll punch those holes open for you for Route 53 and for these other various providers. You can also create your own provider for these. If you want to use something like an F5, for example, it would just require using their, implementing their interfaces in Go. Any questions?
Yeah. One more from Nathan asks, it's a storage question. We have a NAS with home directories where each home directory is a separate ZFS dataset and separate NFS export. How can we trick developers to mounting only their home directory in any pod they deploy?
So that goes back into really fine-grained RBAC, and that's well above and beyond the scope of this discussion. It is doable, but it would be RBAC with annotations. That'd actually be a pretty complicated setup on the to do that. But hit me up on our regular channels. Through the various channels, we could talk about that a little bit and unpack that if you need. Here, I'm going to shut down Slack because I thought I had notifications turned off, but apparently not. But any other questions before we move on to the next topic?
Yang asks if Rancher provides monitoring and alerting, so maybe you can cover that at some point soon.
Absolutely. So let's actually touch on that quickly. So monitoring and alerting. Under the covers, we're leveraging the Prometheus Alert Manager, and in later versions of Rancher, we actually plan to fully wrap Prometheus and Grafana into how we expose monitoring to the world. But we do provide a number of alerts, and you can customize your own alerts around the health of cluster services, application events, and the like. And then we have what's called a notifier. So these notifiers tie into existing alerts. So you'd create an alert for your application or for your nodes, and then create a notifier. So, and this is all just part of Prometheus Alert Manager under the covers. To either send alerts to our notifications to Slack, to email, to PagerDuty, or anything that supports a webhook. So a lot of your notification platforms support HTTP webhooks. So as long as a webhook URL to feed into your alert, it'll work just out of the box. Anything else before we move on?
That's it, sir.
All right. So these are available at both the cluster level and at the project level, and even at the global level. We have the ability to do that as well, to monitor things that are going on with Rancher. You can see here my DigitalOcean nodes, they're up and running. Still kind of waiting on my my Azure nodes to spin up and running. I bet if I went to did I not save it? Oh, I didn't save it. No wonder I haven't spun up yet. So once those actually come up and running, they'll be available with my platform. I was a little surprised to still see 3 here. So we've talked about setting up clusters. We've talked about authentication and security. We talked a little bit about storage. Let's talk projects and namespaces next. This is another kind of killer feature coming from a Kubernetes background of working within clusters. So every Kubernetes cluster has a set of namespaces, and by default, you get default. We allow you to group namespaces into projects, and projects is our construct. So this is a construct that is defined through our custom resource definition in Kubernetes and exposed through our custom resource controllers. But we allow you to create multiple to create a project that has access to multiple namespaces, and it's a one-to-many relationship. One project can contain many namespaces, but a namespace can only belong to one project. So for every Kubernetes cluster you import, you will get the default namespace in the default project. I have other namespaces here for like an NFS provisioner that I created earlier, and then items that are not within a project by default. We're creating a paradigm for a system project. It's not ready yet. I think it's targeted for like 206. Don't quote me on that. It's just off the top of my head. But we also don't put our cattle system into a project or the Ingress Nginx namespace into a project. So when we spin up a cluster on your behalf, we spin up the cattle system, which is all of our bits, and the Ingress Nginx, which is our default Nginx Ingress controller. If you don't like the way we do Ingress controller, delete the Ingress Nginx namespace, and it will just go away. The same thing goes for Rancher. If you absolutely hate Rancher, but you still love the Kubernetes cluster it created for you, you can delete that cattle system namespace, and all of our bits go away, and you're left with a vanilla Kubernetes cluster with Canal or Flannel or Calico already installed, and some annotations that we'll leave around, but nothing that will affect the operation of your cluster. At the end of the day, your Rancher has gone away. We'll stop managing your cluster, but your cluster still exists. Everything you install and is running on there, it still exists, but your Active Directory or Azure AD-based authentication won't, because we're managing that for you. All the things that Rancher manages are just gone. But your cluster still remains. Like I said, we're here to enhance your Kubernetes experience, not to get in the way. So from a project setup, we can just create projects on the fly. My project. And we can actually set pod security policy for the project. I don't have any pod security policies running in this demo environment. All you need to know is pod security policy is a first-class Kubernetes construct that allows you to define what your pods are allowed to do on your infrastructure. So if you want to prevent things like root escalation and things of that nature that are Docker security issues, you can do that through pod security policy and restrict the user and volumes. Actually, the question earlier about how to restrict specific users to specific volumes, you could do that through a combination of project and pod security policy, and create a pod security policy that only allows a developer to see their own volumes from NFS, and then make sure that the projects they have access to only have access specifically to the pod security policy that is those volumes, for example. But I could create a project right here and create multiple namespaces. Oops, I hit F11, excuse me, and F12 at the same time. I fat fingered it, and I create that in my project. And now my namespace 3 is only available to my project, and members of my project only have access to that namespace. But because I'm a super user and I can see everything, I can go into my kubectl. Oops. I can go into kubectl and see the namespace I just created. So I not just have the default namespaces, I also have the namespace I created, as well as the other ones that have been created as part of this demo environment. But that being said, we're just making it easier for you to create namespaces and give out access to them as needed. So if you were to add a user to that specific project, they only have access to that namespace. They can't see cattle system. They can't see Ingress Nginx. If they're authenticating either through kubectl and the kubeconfig gave them, or logging into Rancher and opening up kubectl, they'll only have access to that namespace and the items running within that namespace. That also gives you the ability to do the fine-grained access control, which is really the other big deal within Rancher, is that we give you the ability to set up control not just to the various Kubernetes items, but also to the various Rancher items. So if I were to add a role here and scope it to project, if I make a member a user of that project role, then I can have them inherit from a base role. So if I created a base dev role, like this base dev team, and so every new project dev would inherit all the things that were in the base dev, for example. So if I were doing a multi-tenancy type of deal, I could create a base developer that is scoped to project, and then go through and every new project that comes on board for my multi-tenant project, we get that base, and then also be given resources, more controls for their specific project. And roles can be all, which means every Kubernetes cluster and the Rancher server stuff as well. A cluster, which means an individual cluster, or a project, which is just the set of namespaces they have access to. So really, really powerful, still really powerful within a cluster, only powerful within a project. And then the fine-grained verbs and resources. And it's not just the Kubernetes resources like pods, for example, but also the Rancher resources like notifiers, for example. So you can do fine-grained access control over both the Rancher bits and the Kubernetes bits. So you have your CRUD operations as well as watch, list, and get. But you have really, really fine-grained access control that you can group into roles, projects, or roles and namespaces. So you have the ability to do multi-tenancy with single cluster manager. Paul's here for questions. I just covered a lot there.
No questions, actually. People just attentive and listening. So keep going.
Then we talked about storage, project namespaces. Let's talk about app catalogs. So if you're familiar with Rancher 1.6, everything was done through Docker Compose. In Rancher 2.0, everything is done through Helm. So I can actually set up catalogs here. Helm is like the Docker Hub or Docker Store of Kubernetes. And Helm supports more than just Kubernetes, but for our context today, we're just talking about Kubernetes support. So Helm is a format for basically creating applications that are either single container image or multi-container image applications. So I'm actually going to enable the Helm stable. So there were 3 out of the box. There's our library of curated applications that are maintained by Rancher, a Helm stable, and a Helm incubator. If you want to learn more about Helm, just go down to helm.sh to learn all about Helm. And Helm is just a package manager for Kubernetes. And it works with the idea of charts. And a chart is basically just a templated YAML file defining all of the Kubernetes type bits, but with actually their Go style templates of fill in the blank for your application. Our curated Helm charts are simplified versions of ones that are out in the Helm stable. If I were to go out to here, I'll go to Helm stable GitHub. We're just surfacing what's in here. So all of these various applications that we know work within Kubernetes are available here in Helm Stable, and we're just surfacing them through a pretty UI. If you would like to have your own charts out there, you basically just need a GitHub. You basically just need something that is servicing up Git in a way that looks just like these charts, for example. So you'd have to create a repository consistent with repository structure laid out here, and consistent with the chart format here as well. So we give you the ability not just to use ours or the out Helm ones, but also create your own, which you could add a catalog right here. I don't have a catalog available to me, but you go in and type the name of your catalog, the URL, and eventually we'll support more than just Helm, but right now only Helm catalogs are supported. But this is how you would have a private app catalog. So you can create your own private GitHub repo that has the Helm charts in a curated format, so you have trusted applications for your application teams to ingest. So if you were using Kubernetes, for example, to create a managed platform as a service for your organization with a trusted catalog and trusted a trusted image repository. You could create your trusted image repository and then create your trusted application repository. Your trusted application repository is using trusted images, and everything is trusted and copacetic with your InfoSec team, as opposed to having to worry about what's out on Docker Hub. And there are ways to make sure you're only using trusted repository inside of Kubernetes. There's image pull secrets and admission controllers well outside of our conversation today, but it is available to do that if you see fit. So if I want to use one of these applications that is out there in one of my clusters, I would go into my catalog apps. I already have my NFS provisioner was one. You just delete it real quick because I like walking through it because that one's really, really simple. So I have here all of the curated by Rancher, as well as all of the various public applications available. Everything from ACS Engine, which is how AKS works, down to WordPress. I know it's down here towards the bottom. I've not worked with etcd before, but yeah, just about anything you could want to run that you probably know about is available in Helm Stable, including our very own NFS provisioner. I would hit View Details, and I would basically just fill in the blanks. In this case, the NFS provisioner is really, really, really simple. And all it's asking for is, hey, where in my NFS, where do I want to serve up things from NFS? So the NFS provisioner actually creates NFS servers on the fly within your Kubernetes cluster, and exposes them to your various applications, just like any other NFS server would. But you can see here, this is what a Helm chart looks like. Is it has, so we look at the daemon set that gets run. It looks just like any other Kubernetes daemon set, except it has templated items. So you would basically put in the different blanks here, and it would go about setting it up as setting it up as you want. So if I were to change the port from 2049 to something else, it would fill in that blank into this NFS host port here. But depending on what you're using, like if you're using CouchDB, for example, there are a whole lot more blanks to fill in. This is simple, but I would launch this, and this would go about running my NFS provisioner deployment, or the daemon set, and all the other template, fill in the blank templates. And once it's up and running, I then have, actually it's already up and running. I have 2 NFS servers running as a daemon set for my 2 workers that are available within this specific infrastructure. But that's how you do curate catalog. Any questions here before I move on?
Yeah, Powell asks, how can I add a Helm chart repo from GitLab or Bitbucket?
So that would be, if I go into global, I can go into my catalogs. It would just be a matter of, if for my GitLab one, it'd be GitLab and the URL it would be the Git URL for that. So I think Jason Great actually has one of these that he uses as example. So I got Jason Great. I believe he has one here that is one of his repos around Helm charts. So if I look for Helm Rancher server, Helm catalog, yeah. So he has his own curated one, which is, I think it's just a fork of the Rancher ones, but that's his specific Helm Rancher server. Yeah, he must remove the repo, but it has a set of chart repo. So he has a set. Actually, this is the Rancher ones, but this is a good example of what one looks like anyway. So we're gonna copy that, and we'll just open that here. No, maybe not. So essentially, the GitHub, your GitLab Git repository that looks like Helm charts, that's what you would add into this specific URL here. So it'd be your .git for GitLab. And the same would go for any other private Git repository that you wanted to add here. Any other questions?
Yeah, one more from the same person, Powell. Do I need to create a project for many or one-to-one microservices?
It's however you want to do it. The project in this case is one or more namespaces. So however your strategy is for managing your microservices will be how you can create one project for all your namespace microservices, or you could create project per microservice. It's how much RBAC do you want to manage? How complicated and fine-grained do you want to make your RBAC?
Okay, cool. All right, that's it. Keep going.
All right, and we see here my AKS went about spinning up those other nodes I asked for, and they're now available to me, as I mentioned earlier. So regardless of whether you're managing the IaaS yourself or having somebody completely manage your cluster for you, our various controllers that are running inside of Kubernetes will check constantly the state of that, and when they're up and running, you'll get them right here. So let's talk about CLI, API, and kubectl. So we're not getting in the way of all of your CLI. So as I mentioned earlier, my inside of VB. Okay, I am actually inside of my Linux server. So I have kubectl. I don't have kube on here, do I? No, I don't. I don't have that one on my laptop eventually. But let me tmux in again. And you can see here I'm currently in my AKS server. But let's actually go ahead and use my authentication from DigitalOcean here. I'm going to go in and grab my kubectl. And I would just go in here and I'm just copy the clipboard right here. If you don't have kubectl, you can download it right here. There are lots and lots of ways of downloading it. This will take you out to Kubernetes. If you're using Azure, for example, there was that Azure command where you can do it. It's an Azure AKS, I think it's Git client or something like that, and it'll actually download kubectl on your behalf. But we're going here and take that what's in my clipboard, and I'm going to do a vi into my home directory .kube /config. Or sorry, I'm gonna not there. I'm gonna cd into there. Oh, I'm using my Windows slashes, not my Linux slashes. This is the problem with doing both a lot, is I mix them up occasionally, and Windows understands both, but Linux does not. And you see I have this config file. I probably already have data for my AKS demo in here. Let me vi into it. If you like Nano, use Nano. If you like something else, use something else. I already have my DigitalOcean in here because it's what I was using earlier. And then my AKS demo as well. So I'm actually I could just paste this in here if I wanted to, if I was going from fresh. I'm not, so I'm just going to switch over my context. Like I said, there are a couple of tools which are not Rancher tools that I would recommend you go find. One is called kubeps1. I'm using the tmux variant of that, but if you're not a tmux person, you just want to on your line, go get kubeps1. And there's one called kubeNS and kubectx. Go get those. If you're running Kubernetes from the command line, this will make your life easier. So I'm going to kubeNS. I'm going to kubectx into my digital. I think it's called DigitalOcean. I switch my context. You see right here, I'm now in my DigitalOcean and my default. And so I can do a kubectl, get NS, and this is all the namespaces with my DigitalOcean, including my namespace 3.1 because I have access to that. So because I'm a super user, I see everything. But if I'm a limited user and I use that config file, I now have access to only that. But just like that, just grabbing that config file and integrating that into my into Kubernetes, into my config, I could do that. I could have multiple config files, and it would just be a matter of changing. There's actually a whole article on this. Because if you're managing via kubectl and Rancher, you're going to have multiple clusters, and this is Kubernetes and it's the kube config environment variable. Here it is. There is this article out in Kubernetes under organizing cluster access using kube config files. So you can have multiple kube config files, and if you use the kube config environment variable, this is a either a semicolon delimited environment variable in Windows or a colon delimited file in Linux and Mac that spells out your kube config environment variable. It would be, in my case, it'd be home directory /.kube/config. And if I wanted to keep a config per environment, then I would just keep adding those separate environment config files to my kube config variable. That way, my tools like Kubernetes and kubectx know with their code complete, which I don't have for my SSH window, but would know that I have those available. So I could do Kubernetes, do my command line completion, and it would actually give me all the context and all the namespaces available based on which cluster I'm involved in, or all the various all the various config files available to me. Also, as well as the kubectl that works, you can also use the Rancher CLI to do Rancher things from the command line as well. I'm going to download it, not Mac OS. I'm on a Windows machine. I need the Windows version. So I'm going to download the Windows version. It's a zip file. I'm just going to save it into my downloads. Go into my downloads. Open containing folder. Always go into properties. And if it's something you trust, you have to unblock it. When you're in Windows, we're going to extract all of that here. That's fine. And I used to have a little tool in my older machine that would open up a shell right there for me. I don't, so I'm going to go. It would help if I'm not fat fingering things like E. Oh, I'm still in my Linux machine, excuse me. Oh, still in my Linux machine. All right, back into my Windows machine. And then if I go /rancher, I have the ability to modify many things that I can do from the UI here from within the CLI. So if I actually want to spin up, manage my Opera2 cluster operations, things like that, I can do that, but I do need to log in first. So logging into the Rancher CLI, I need a couple of things. And I'll need a token. And I won't go through all this because we're just about out of time. But if you want to create a token for logging in from the CLI, which is what you'll need two things. You'll need the CA certs because I'm using self-signed certificates, or maybe I'm using certificates that are not available on my local machine. So I would need to make sure I provide to my users, if I go into settings and CA certs, I'd have to provide this certificate to my users if they don't already have it on their machines, and I'd have to give them a token. So I have my API and keys right here, and I could create a token specifically for my user or for my CI/CD system right here. And I can see, and this could expire never, or for limited access to the CLI, I would create that key. And just like if you're using a key in creating service principals or creating DigitalOcean API keys, this is only available here, so make sure you copy and paste it. But it gives me an API token specifically for my CLI that will expire in the amount of time I gave it. This is separate from your user-based authentication. So even if you erase users, if they have tokens lying around, you need to make sure you have some way of managing their tokens. Otherwise, they'll still have access to your Rancher system if you remove them from the end user store. So we're a little bit over time. Any more questions before we end for the day?
Let's see. There's, I think you actually answered this already, but Powell asks, can I use a private GitHub repo and how?
So We talked about a private catalog. We did not talk about private repo. So for each individual cluster, you can actually go into, actually for each project, these are project-based. If I go into resources and registries, I can add a registry. And I can specify that registry is available to all namespaces or a single namespace for the project. And if it's one like Docker Hub or KIO that we already know about, we can type it here along with username and password, or a custom one, which is your index dot whatever your private URL is. And if it's authenticated, you need to add it in here, username and password. And what that does is that will add what's called an image pull secret in Kubernetes. So when you're pulling from those repos, it actually inserts the image pull secrets. If it's not a protected repository, you're going to workloads, and you are actually going to deploy a workload this way, you'd have to go in, and when you specify your Docker image, it would just be myrepo.io / the Docker image name.
Awesome. Okay, this is the last question, Jason, and then you are free. You did so good. Thank you so much. This is from Yang, and he says, what's your opinion on the difference between Rancher 2.0 and OpenShift? What's the pros and cons?
So, I mean, that's a big question, but honestly, it really boils down to, would you prefer Red Hat's ecosystem where everything is Red Hat branded and the Red Hat way of doing things, or something that is more vanilla Kubernetes oriented? So we are mainline open source Kubernetes. When the new versions of Kubernetes come out, you could create a 111 cluster today and import that right into Rancher. Even though we're not building a 111 cluster for you yet, we will soon. There's nothing to stop you from doing that. In an OpenShift world, you're using the OpenShift trusted version of Kubernetes. You're waiting for them for their updates. And I've got no problem with OpenShift as part of the community. I like what they've done. I also like what Rancher is doing. It's why I work for Rancher. So take that bias for what it is. But even before my Rancher days, this is the conversation I would have as an enterprise is, if you're already buying Red Hat and you get OpenShift for free, maybe that's worth your time. But if you don't want to be locked into Red Hat and locked into that contract, I would suggest you go into some sort of management platform that works with vanilla Kubernetes. And also there's some issues around how we can do multi-tenancy versus how they do multi-tenancy, how they handle namespaces versus how we handle them. So analyze some of those idiosyncrasies, and I would highly recommend that if you're already a Red Hat shop, look at OpenShift before going out and looking at Rancher. We're not the only way of doing things out there, and our way works great. But maybe within your enterprise, OpenShift would be better, and you'd be beating your head against the wall by trying to adopt something like Rancher in your enterprise. By all means, I actually have I have friends who are at a major Fortune 50. They wanted vanilla Kube, but their enterprise architect said, "Hey, we already have all this open. We already have everything in open, or everything is Red Hat. We pay for huge amounts of Red Hat licensing, and we think OpenShift will work." And they've decided, we're not gonna fight that battle. We're just going to adopt OpenShift, which gives us the Kubernetes we want without the battle we would need with our enterprise architects, and it's just going to work. And so that limits them to being within the Red Hat ecosystem, but that may or may not be a problem for them down the line. But it just means they can adopt Kubernetes now within the context of their organization versus having to fight the battle to do vanilla Kubernetes.
Great. Okay. Thank you, sir. That was the last question. And with that, I'm gonna take the presentation back. Is there anything else you wanted to end with before I show the last couple slides?
As I mentioned, feel free to hit me up on Twitter anytime. I'm at Jason Van Brackel. I'm also out on the Rancher user Slack, as well as the Kubernetes Slack. I'm also at JVB there. If you're local to the Philadelphia area, as I mentioned, I'm the organizer of Kubernetes Philly. It's just meetup.com/Kubernetes-Philly. by all means reach out to me. Come out to one of our meetups if you're on the East Coast. And I travel occasionally, so when I travel, I try to look for meetups in the area. So if you run a meetup somewhere in the country, or you're part of a meetup somewhere in the country, let me know about it. So when I travel to that area of the country, my first territory is from Maryland south and down to Latin America, but it's just out in New Mexico last month, and I couldn't find a meetup out there to go kick in on. But hey, if you're part of one or you want to come have me speak, I'd be more than happy to do just a Kubernetes demo or a Rancher demo for your organization or your meetup, and reach out to me.
Amazing. Thank you, sir. Such a resource. Well, on that note, I just wanted to end with this slide, slack.rancher.io, so you all know you can continue the conversation and plug in with the community. These slides will be emailed to you along with the video recording and the list of questions. And that's all we have for you all today. I hope everybody has a great end of their week, and we'll talk to y'all soon. Thanks so much.